Hi everyone, this is Tanisha from Initiative Bangladesh. Today we are going to work on a question. Why does wood float but rock sinks? To understand this, first we need to figure out why anything floats or sinks at the first place. We have all heard about the term buoyancy, which refers to how well something floats or sinks. If something is able to float, we would say it is buoyant. Generally, whether an object is positively or negatively buoyant can be understood from its weight. Usually, if something is light, it floats, it's positively buoyant. And if it's heavy, it sinks, it's negatively buoyant. This is an easy enough explanation for us to accept, right? But the idea becomes shaky when something really big, like a cruise ship, is able to float. To understand this, we need to understand the concept of density first. What density really is. Density is the amount of mass something has relative to its volume. For example, imagine a bucket full of sand and an empty bucket. Which one is more dense? Surely the one with more stuff, right? So what does this have to do with buoyancy? To understand what's the relationship between buoyancy and density, we need to tackle a bit of Archimedes' law. According to Archimedes, the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially immersed, is equal to the weight of the fluid that the body displaces. Complicated much? Let's break it down. Basically, what Archimedes' principle helps us to understand is that if an object is heavier than the amount of water it displaces, then the object will sink. And if the object is lighter than the amount of water displaced, then it will float. Let's understand this from an example. Imagine a basketball and a bowling ball. The bowling ball is not only denser but also is heavier than the displaced liquid, so it sinks. On the other hand, the basketball is less denser, displaces more liquid than its weight, so it floats. Here, what is buoyancy? We are mentioning this term so much. Buoyancy is the upward thrust that the body receives. As we got to know from the law, this upward thrust or buoyant force is equal to the displaced liquid. So in case of a sinking body, weight of the object is more than the buoyant force. And in case of a floating body, the buoyant force must be more than its weight. And that's the reason why it floats. But what if the weight of the object is equal to the buoyant force acting on it? In such a case, the object will float being fully immersed in liquid. Here, weight of the object will be equal to the weight of the displaced liquid. Now, I guess we can understand a bit of why the cruise ship doesn't sink. It's because even though it's very heavy, it's large and most of the ship is hollow. So it's not as dense as you might think. Because of this, just like the basketball, the ship is lighter than the water it displaced, causing it to float. Now we have understand the basics of density, buoyancy, and why does a cruise ship sink. So let's solve a problem. The question is, if a piece of wood floats on water, what percent of it will be immersed? The density of wood is given and also the density of water is given. We know in order to float, the weight of the wood must be equal to the mass of the water displaced by the immersed part of the wood. That is, if volume of wood is V, then its mass will be V-rho, and if the volume of the immersed part of the wood is V1, the mass of that amount of water is V1 rho W. We know mass doesn't change, so surely the initial mass will be equal to the final mass, that is V rho equals to V1 rho W. Then we have established a relationship and found the percentage of the amount of wood that will be immersed. They could have asked us about the relationship between the initial volume and the final volume. In that case, we could have written that V1 equals to 50V, or the relationship between density, that will be rho equals to 50 rho W. So that's it, guys. I hope you guys have understood. Thank you so much for watching. Follow Initiative Bangladesh for more content.